Hello, everyone. Can you hear me?
Yes.
Yes, we can.
Yes. Yes. Good. I hope you're having a fine day today. So we will be starting our live. We'll wait a little bit for people to join the live, I think. So I guess we're gonna start now. Hello everyone, my name is Ayman Finkouch, currently student at NCS and event manager at the NCS IT Club, who's jointly organizing this event and live. I would like to thank you all for your presence today and for being here with us. I would like for each of you to present yourselves. So, what in general the presentation that you'd want to do. So we're gonna start with Sir Jan, if you would like to.
Yes, hello. My name is Jan Civron. I work for JetBrains as a developer advocate, and today I will talk about the plugin development for the IntelliJ platform a bit, and hopefully also show you a bit how plugin development looks like in the IDE.
Yes, we'd be very excited to see that with you today. Next, Alex, would you like to introduce yourself?
Yeah, sure. So my name is Alexander. I'm a consultant at a company called J Driven in the Netherlands. And well, I made, well, I don't know if you can call it a plugin, but I had this idea of turning IntelliJ into a game engine, and that is all I'll be showing today.
Very good. Then will be Miss Sarah. Can you please introduce yourself?
Yeah, sure. So, hello everyone. My name is Sarah Atef. I'm an assistant professor at NCS DT in Terudant. And today I will be speaking about Google's latest, kind of like AI capabilities that can help developers.
Okay, very good. So we'll start with Mr. Yan. So plugin development, right?
Yes, yeah.
Go on,
Okay.
the stage is yours.
Yes, let me quickly share my screen. There it is. Okay, can you see my slides?
Yes, we can see them.
Okay. So hi, greetings from Germany, and I would like to talk a bit about plugin development today. Unfortunately, I won't be able to stay after my talk, but I'm happy to take questions just after my talk. And I will also give you some pointers on where you can ask more questions and join the community we have around plugin development. So, quick bit about me. I've been using IntelliJ for half of my life now. I wrote my first plugin about 20 years ago. Maybe some people remember the Struts web framework from Apache back then. And I've been with JetBrains for 13 years, now working as a developer advocate for plugin development. So what is the agenda for this talk? I'll quickly talk about the IntelliJ platform as an ecosystem. I would also like to stress when not to write a plugin, because it's actually maybe not a good idea in some cases. We'll take a very quick look at what key components are there in the IntelliJ platform that you will encounter when writing plugins. I'll show a bit about plugin tooling, but we actually did a webinar just 2 months ago, so you can go and watch that instead. And then I'm happy to take some questions from the audience. So the IntelliJ platform ecosystem. So there's not only IntelliJ IDEA, but quite a lot of IDs by now. It happened in 2009 that IntelliJ IDEA was split into a platform and then IntelliJ IDEA. So these are two different things, at least on a semantic level. It's Apache 2 license, so everyone can go and reuse and use the code to whatever they like to do. It's important to note that this is not a general rich client platform, unlike, for example, like Eclipse RCP, but only really for development tooling, or IDEs basically. We've successfully removed any traces of Groovy in our code base just last year, and we are increasingly writing new code in Kotlin. The UI is actually using Swing. Many people don't believe that, but it's actually possible to write performance Swing applications in this time. So what is there in the platform? There's quite a couple of IDEs from JetBrains. You might have heard many of these names already. Then there's, of course, Android Studio from Google, which originated from the Android plugin from JetBrains. And then there's a huge plugins marketplace where you can download all sorts of plugins for the IDEs, nearly 10,000. So we will probably reach 10,000 in the next couple of months. A couple of links for you if you want to go deeper. So the sources are available on GitHub, of course, issue tracker. Then there's the SDK docs, which our team contributes to a lot. We have a very vibrant community of plugin developers hanging out in our Discord. And of course, you can also get help for plugin development questions from our team, or follow us on social media. So before we start talking about writing plugins, we will talk about not writing plugins, of course. So what alternatives exist? One very popular alternative is structured search and replace. So that is basically something like regex for code that the user can configure, and this can help highlight specific problems in your code base. For example, if you have some specific framework or specific rules in your project, then you can use SSR inspections to highlight such warnings in your code without coding any line in a plugin. There's the IDE scripting console, so you can basically use the platform API from scripts. There's an experimental Flora plugin, which uses a JavaScript interface. And then there's the Live plugin, which is a third-party plugin that allows you to use Groovy and Kotlin to write very small plugins that can also be shared in the project. So that is really a very good alternative if you don't have very complex functionality that you want to distribute in your team. This is a very good alternative. And you can read more about these on the SDK docs. So let's take a look at the IntelliJ platform. There's a lot of infrastructure that we give you in the platform, of course. We have various scopes, for example, the application and project scope. There's a messaging API. There's, of course, an API for settings and persisting settings. There's a virtual file system which abstracts away all the interactions with files wherever they are located, on local disk or on FTP server or wherever else. And then probably the most impressive or powerful part is the program structure interface, short PSI. And that is basically a semantic model of the code that the IDE builds for you. And as a plugin developer, you can hook into this PSI and use it to understand the code and the project and manipulate it as well. For the user interface, there is a Kotlin DSL language for building forms. There's plenty of built-in UI components that you can use. There is a possibility to theme the IDE. There's plenty of theme plugins as well on the marketplace. Internationalization is, of course, also possible. And then there's a lot of core functionality like error reporting, integration with help systems, accessing network resources, and all of that. So basically, you get a very complete infrastructure functionality for your plugin that you can reuse and build up on top of. So some key components that you will see when you write a plugin are, first of all, actions. These are invoked by the user explicitly in the UI, for example, via menu or via a toolbar button, and these invoke business functionality, whatever that may be. The next very important point are extensions. So these are basically callbacks that the platform offers you, for example, to register a new language or a new editor type in the IDE. And you can implement this functionality, and the IDE will basically augment all the functionality with the contributions that your plugin offers. You can have services in your plugin to manage logic or state. These are usually singletons, and they allow you to connect all the different business functionality in your plugin, for example. And then there's a very powerful listener messaging API that you can use to react on messages from the platform, or even build your own messages and topics if you need them. All these things are registered in a metadata file called plugin.xml, and we'll take a look at that later on. So this is basically the basic structure on the file system for an IDE plugin. The distribution is basically containing all the necessary compiled classes, of course, and then in the meta-inf directory we have the plugin XML, which has all the metadata registration for all the components that I just mentioned, and the plugin logo, which is of course also very important to have. How do you start a new plugin? I think there are two ways right now. One is using the IDE. There's a project wizard that will generate an empty plugin for you that you can start building on. And the other alternative is using a GitHub template that our team has built and managed, and that has also completely built-in CI integration with the GitHub Actions. So you will be able to build, test, and verify your plugin on GitHub. Everything is basically there for you already out of the box, and you can even release your plugin from GitHub automatically. So that's very convenient. If you want to build a theme, then you can also use the integrated project wizard as a special variant for building theme plugins there. So if you have built a plugin, how do you deploy it? The most common place is to publish it on the JetBrains marketplace. There's also a service for enterprises called IDE Provisioner from JetBrains, which you can also use to have some kind of internal plugin management in a company. And you can also host and run your own custom plugin repository, which is basically just an HTTPS server that delivers the metadata and the plugin distribution files. So a very quick run around the tooling. So we have various stages, of course, in the tooling. We have the development phase where we have the plugin dev kit. So that's a plugin that you install in the IDE to develop plugins. So that's kind of meta. There's a bunch of tools built into the IDE which can be activated in the so-called internal mode. That is basically for debugging the IDE state. And we have also built the IntelliJ Platform Explorer, and that allows you to search for code samples in open source plugins by looking for implementations of the extensions. So basically looking at how other people build functionality for a certain API, and then you can learn from that and build similar things in your plugin. That's very convenient to look for sample code. If you build a custom language support, we have also the so-called grammar kit, which allows you to edit the grammar and the syntax parsing configuration files to build a custom language plugin. So to build the plugin and to have the infrastructure to run all the necessary tasks, there's the IntelliJ Platform Gradle plugin. So that is the official way of building plugins for the IntelliJ platform. That is also maintained by JetBrains. And it has all the tools to build, test, verify, release, all sorts of tasks, specialized tasks are available there. Once your plugin is ready, you should run it through the plugin verifier, which will test a lot of things in your plugin distribution and also make sure that the compatibility is matching for various IDEs or various IDE versions, for example. And then we also have a couple of internal tools. I quickly show two of them, the IntelliJ API Watcher and the Exception Analyzer. So the plugin dev kit is basically code insight inside the IDE. There's a bunch of inspections as well. If you're interested to learn more about this, we did a webinar about this plugin dev kit and many other development tools just 2 months ago. There's all the details there, so I will show it quickly later on. Same about the internal mode tools. There's a bunch of things that I can also quickly show maybe today, but if you want the details, go watch the webinar. The Gradle plugin is basically setting up all the dependencies that you need so that you can target the IntelliJ platform in a specific version, for example. It will verify your project setup. It will help you run the test. It can run your plugin in a so-called sandbox IDE instance where you can test it in live IDE and check the behavior and debug it in the live IDE before you actually deploy it. And it will also, of course, generate the plugin distribution and help you to publish it on the marketplace. The plugin verifier is also available from the Gradle plugin, and it will generate all sorts of warnings and deprecation, highlighting compatibility issues, and all sorts of general plugin distribution issues. So here's one sample output of what the verifier found in the plugin. You can see there's quite a lot of issues with this plugin that you should hopefully be able to fix before you upload it on the marketplace. So a look behind the scenes. Nobody has seen this outside of JetBrains. So we have, of course, a very big API coverage in the platform, and the plugin API, of course, changes. And for us, it's very important to keep the plugins compatible across multiple versions of the IDE so that plugins keep working, especially if plugins are not actively maintained anymore. And this tool allows us to search for usages in existing plugins from the marketplace. So we can actually look who is using our API and how. And whenever we, for example, need to remove or break an API, we can use this tool and then reach out to plugin developers and let them know that they need to adapt to some changes that will come in the future. So no plugin is perfect. There might be exceptions in your plugins, and there's a built-in exception analyzer in the IDE that will show you this dialog, and users can then submit errors with your plugin, and your plugin can then process these errors. We offer on the JetBrains marketplace, we offer a built-in exception analyzer that you can use, but you can also hook into this reporting and provide some custom logging of errors into any system that you want to use instead. So that's about the slides. Let me quickly see if we have already some questions or comments. Yeah, so comment is one of the biggest difficulties is to find in the documentation what you need to find. Obviously, there's a search function here, but I recommend to take a look at the Explore the API page, which gives you a lot of hints on how to locate where functionality is or is not available in the platform. And it allows you to find strategies that will help you discover the API or any kind of sources that you need to take a look on. I would quickly like to demonstrate you a real plugin, sample plugin, that will show a dialog in the IDE. So it's not a lot of great things happening, but it would show a dialog about the currently selected element. So we can inspect how the IDE gives us also information. And I will now just press start. So the Gradle plugin has now launched a sandbox IDE instance with this plugin, and I can now invoke the action from this menu here. And we can see the dialog now, and it also shows us the selected element, which is basically the element that I had active here in the project tool window before I invoked the action. So that's a very short demonstration of a real plugin, and we can also see the plugin dev kit in action. Here we have this nice gutter icon, and this allows me to jump to the declaration in the plugin XML file, and the plugin XML file has all the metadata for this plugin, so a name, for example, description, and then we have all the actions that are provided by this plugin, and they are registered here. And of course we can also navigate back to the code from the metadata files and so on and so on. There's a lot of code insight as well in the plugin dev kit, so nearly all the attributes have code insight. We can navigate and understand the relationship between all the metadata as well from this editor. Another quick thing I can show, maybe if I find the right, yep. So I pressed some magic keys and clicked somewhere, and now I invoked one of the many internal tools that are available for plugin developers or for anyone who wants to understand what the IDE does. So this is the UI inspector, and now I can take a look at all the UI elements. This is basically the UI tree in the Swing interface, and we can now look at the underlying code that we have here, and we can even navigate here to the code directly from this UI inspector. And of course there's much more to tell. I have of course only limited time today to show and talk about these things, but I hope this gave you a very short first insight of what is available in terms of tooling as well. I quickly want to show the other two important websites. So this is our discussion forum, the JetBrains platform, and there all sorts of plugin developers ask questions about plugin development, and employees from JetBrains will answer the questions here. So this is probably the best place if you are really stuck with plugin development questions. And then we have the JetBrains marketplace with all sorts of plugins that you can download and that are available also for inspection. The last thing I want to show is the Platform Explorer. So we can now look for a specific extension, and now it lists all the plugins which use this extension. So I can now go and see more information about this plugin, and I can now click here. Oh, okay, this is obviously obsolete. Let's try something that is definitely maintained. I can now go on GitHub and see directly the implementation of this extension. So this is really a very good way to understand how other people implemented code in their plugins. So I can basically look at other people's code directly from this Explorer and find implementations of this API in 2 mouse clicks. This is a real huge time saver for plugin authors. All right, so that is basically the introduction about plugin development for IntelliJ.
Yes, thank you very much, Jan, for this introduction. Very, very insightful. You've shown us a lot today. I'll see if the audience has some other questions concerning plugins. It's really interesting to see how the plugin ecosystem is developed in the JetBrains. It gives the community the chance to contribute, and that definitely makes the product more attractive, in my opinion.
Yes, of course, yeah. One thing I didn't mention is, of course, you can also offer paid plugins on the marketplace if you like to, or freemium plugins, so you can actually start running a business around plugin development, and there's actually quite a few people doing this quite successfully. So if you have a really good business idea, this is also something to look into maybe once you are a very good plugin developer, of course.
Oh yes, that's definitely very interesting.
Yeah. Of course, I want also to encourage everyone to look at the existing plugins because there's really, really a lot of plugins available on the marketplace. And I must say that really most of them are very good in what they do and what they promise. So if you ever think that, hey, how can I do this or do this faster or more easier, there's a good chance that there's already a plugin out there on the marketplace that you can simply download and use for that. And yeah, so yeah, there's a huge ecosystem, a huge world to explore. I hope that I gave you a few insights, a few ideas, and maybe one day we will meet on the discourse or see your plugins on the plugins marketplace.
Yes, that will be a very good thing to have. Thank you very much, Jan. I think there are no more questions about plugins.
Yes, okay. As I said,
so-
I have to leave now, unfortunately, so I hope you have a great presentation.
No problem. Once again, thank you very much for your presence with us today.
Thanks for having me. Take care. Bye-bye.
Thanks. Okay, so now I guess we'll go for Alexander. Would you please
Yeah, sure.
go on? The stage is all yours.
All right, I'll share my screen. Okay. Let me check. Should be visible now, right?
Yes, it is.
All right, great. All right. Yeah, so I'm going to talk a little bit about turning IntelliJ into a game engine, well, using the plugin system. So a lot of things I used were just shown. So it's nice at least that I that I use the correct APIs to do what I did, I guess. Very short about me. My name is Alexander Gatzagarias. I live in the Netherlands, but I'm half Greek, and I work at a company called J-Driven here in the Netherlands, which is a consultancy company. And yeah, in my free time, I like to play games and I like to make games, and that's a little bit how this whole adventure started, so to say, because I was looking for a way to make games that didn't involve the big game engines. At some point, I figured, well, I mean, I'm using IntelliJ every day at my work, so why not build my games in IntelliJ, right? Then I can at least game when I'm at work, when I'm working. Of course, there's always some rules when you start a project like this. You don't want to make it too easy for yourself. In the end, we are software engineers. So one of those rules I set out for myself is do not use the Java Chromium Embedded Framework, or GCEF for short. That is something that IntelliJ supports out of the box. And basically, what that is an embedded HTML window within IntelliJ, and there you can pretty much load any website or HTML, JavaScript that you want pretty easily, and then run it. So that would mean that it would make a project like this kind of trivial, because in the end, that means you can just use any JavaScript framework or game framework or HTML game framework and just embed it like that, and you have your game. So we won't be doing that, because again, you don't want to make things too easy for yourself. A second one is myself being a gamer. I know that gamers like their performance, their frame rates. I'm trying to keep everything I do at a high frame rate. And I think overall I did a pretty okay job. So if you look here, one of the plugins, for example, runs at 120 frames per second, or better said, the guideline is 120 frames per second, because in the end you don't have a lot of control on the refresh rate of IntelliJ. And maybe in the future, if this gains traction for some reason, it is something that JetBrains will add to plugin developers, that you can really control the refresh rate of the UI. Of course, it would be kind of boring if we used all kinds of game libraries to make our life easier again. So no game libraries like the lightweight Java game library, which is also what Minecraft was first built on, I think. So this is all just pure code, so to say. And of course, I mean, if we are using IntelliJ as a game engine, might as well see if we can use the code as assets, which would be kind of cool, because that means that every single game or every single code base out there could transform in its own game, or its own experience, which means you have an infinite amount of games you could play in IntelliJ pretty much. So as was just said, IntelliJ is built using Java Swing, which I also didn't believe when I found out. Especially coming from a game engines like Unity 3D, then having to work with Java Swing was quite, let's say, the adjustment. It was really tricky. But yeah, in the end, it works. And I guess, yeah, if it works, no need to change it. And of course, I will using the IntelliJ plugin platform for everything. And the plugins are written in Kotlin, so not Java. Personally, I'm more a Kotlin fan over Java. So that is what I ended up using. And frankly, it did make my life quite a bit easier. So that was quite nice. All right. So I'll just get started and show what I did. If anybody has any questions about how things work or what you could do more, just feel free to ask. I have the comments here up on the screen, so I'll be able to see that. All right. So I have a little bit of, I have a demo application here with just dummy code, so to say. And then I can, for example, say time to play some Pong. And here you can see how we are playing Pong, for example, within IntelliJ. Now, when I made this game, I quickly realized that there is one player that has a significant advantage over the other player, as you can see. But yeah, it was quite well. The graphics are quite smooth. It goes quite fast. Everything is quite nice. So I can't complain. So with this, you can see that you can create simple graphics, You can create simple collision systems. It is not collision like NVIDIA physics level of collision. It is like fake it till you make it type of collision. But yeah, it works, and it's quite nice. And then I can remove this again. And let me just go here and reset the changes that happened. So can continue. Great. So you can see here like this, just a simple Pong game where you can just have a ball go left and right. Quite easy to do. And then I figured out, well, once I have that, once I've shown myself that it's possible to actually make games within IntelliJ without, well, I don't want to say without too much hassle, because there's quite a lot of hassle to make this work. For example, this is the service for the Pong game. It is, and it's quite some code to make it all happen, but it is not overly complicated, I feel. And it all works based on services. So for each game, I have a project level service here that basically registers the game and initializes it, and then I can basically control the life cycle of the game and inject the things I need to make it happen. All right, so after Pong had figured, okay, I need some kind of theme to come up with ideas of what I make. I'll make, and I figured, okay, since I'm a software engineer and this is IntelliJ, let's make games about software engineering. And I'm a backend engineer myself, so I figured let's make games that are more about the backend or the things that a backend engineer can do. And then I came up with State Invaders, which is a play on Space Invaders, which is a very old game. Your students, I don't know. I hope you know Space Invaders, but I'll forgive you if you don't. Yeah, in backend, when we make backend systems or backend services, we really do not like to introduce state, because having state in your backend systems increases the chance of bugs or things going wrong, because different threads change the state of variables. So I figured I would make something fun about that. So now what we're going to do is we're going to collect every single state or mutable variable in our code base. This happens underwater. And then we construct a nice little UI or main menu. And as you can see, IntelliJ is still trying its best to render this or to compile this, which is a valiant effort, so to say. And then we can play start, and then we can even have things like a little bit of a opening cutscene. Now this is a meme. I don't know if you know it. It is the "all you base are belong to us" meme. It is a little bit of the older generation, you could say. But yeah, it was pretty funny to me. So yeah, so as you can see, we can have a short cutscene, so to say, and add some flavor to our games and things like that. And after a while, the cutscene will finish, and then we have the state invaders. Now, I'm pretty bad at my own games, so I have God mode enabled for myself. And as you can see, of course, as you destroy the stateful variable, so every single of these aliens is a variable that can be mutated during runtime, the chance of production crashing is going down, which is obviously what happens when you remove stateful variables. And this is all done by walking the PSI tree that was mentioned in the previous presentation. So you walk down the PSI tree and you basically ask for every variable, okay, is this a mutable variable or not? And if it's mutable, I collect it, and then I construct a little game object around it. And then as you can see, after every time I destroy a mutable variable, I hold a reference to which line number that variable was declared at, and then I just remove it from. I just remove the line, which means this changes your code, and arguably it doesn't compile anymore, which is something I do not mind that much. If I don't care if the code ends up still compiling or not at the end, I just want to have fun, so to say. So yeah, this is quite fun, I think. Right. So and the good thing about source control system is you can clearly reverse it, of course. Now, after showing this, I figured, okay, or making this, I figured, okay, what is the next sin? And that is, and especially when it comes to front-end land, but in back-end land as well, is over lines or packages, just pulling packages left and right, not really knowing what is in those packages or what they do or what they don't do. So I built a little game, based on Pac-Man, which I call Pac-Man with a K, where you are navigating a maze with all those constructed from your dependencies, from packages. And that does mean, of course, that I have to walk through the dependency tree. So I read in the Gradle file or the Maven file, and I create a maze based on that. Now, there is some sound here, so I hope that works all well. If it doesn't, let me know. So here we go. I hope it was also not too loud. It was quite loud for me. All right. So what we did now underwater is we basically went through we read in the Gradle file in this because this is a Gradle project, but it can also read in Maven files, and then you can press start, and this is a maze that is constructed using the strings of those packages, and you can see ghosts roaming around, like the Pac-Man ghosts, but in this case, they are the ghosts of our past selves, of our past mistakes, because every Git commit that added a new package file is here represented, and then we can walk around and see if we can find some of those ghosts. I realized that this is completely random, so it could be that we won't reach any ghosts, but here it seems that we found one. And of course, Pac-Man makes this very distinct sound of waka 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 waka. Well, I couldn't use that, so I did the next best thing. So I hope you can hear this. But Java.
I think the sound on my side, I can't hear the sound.
Oh, all right. Yeah, that's a little bit unfortunate, but I'm not sure if I should take time now to try and fix it or not. But it doesn't change a lot, maybe in the last game, but it's fine. So yeah, and of course, we ate a ghost, which represented one of the Git commits. And when you eat the ghost, basically I go to the line in the Gradle file and remove the dependency because you don't need it anymore. There's a question if there's any limitations to how advanced games we can actually build. Yes, as far as I know, you cannot build any 3D games out of the box because Swing just flat out doesn't support 3D graphics. Because, primarily it's a UI tool, so it makes sense if you think about it like that, but I wasn't that happy about it either. That said, I'm pretty sure you can do some fancy stuff with OpenGL, bindings, and things like that to actually render 3D graphics, but that would take, I think it would take quite some time. That said, you can do multiplayer games if you wanted to. because in a IntelliJ plugin, you can actually do API or external calls to servers and stuff like that. So that's pretty fun. Yeah, while I'm at it, I might as well show this little thing. So I always like playing with explosions and seeing things explode. So I figured, why not explode my code when I'm frustrated or irritated by bugs? So yeah, basically, you can control right click and it will simulate an explosion, and every single letter that is in the explosion radius will become, let's say, a physics object, and then I will keep calculating, simulating the explosion and where they should move. And in the end, of course, because IntelliJ itself is, of course, this document window here is a grid. If you take your cursor, you're basically navigating a grid from left to right. It is quite easy to kind of simulate an explosion and then find out where things should end up in the end. And there's a little snapping to make sure everything has its own place. But it's pretty fun. It was quite cool when I also made a plugin about this. I'll put the QR code in the end. It was fun to get messages from people that were sending me just a picture of a PR with a hole in it, and they submitted it, because I mean everything I do here is just in the document, and that means everything is basically in version control or in Git. So here you can see that this basically changed into a hole where the code was, which I think is quite funny. All right, so moving on to the next to the next game, and the next backend scene, which would be that eternal struggle with unit testing, right? So there are people that love unit testing and test-driven development. There are other people that say it's a waste of money, as long as you have your pipelines correct and everything. You do not need too many unit tests. I'm a little bit in between. I think there is a fine line between meaningful unit tests and just unit tests that are just there for coverage. So I figured I will try to make a little game on that. So here I have just a couple unit tests using JUnit, and when I start the game, gotta go fast. I need to type "We love Scrum" to start the game. We love Scrum. And here we can we have a more sophisticated cutscene, opening cutscene, so to say, where our bad guy, Dr. Velocitnik, is giving us his great speech about how he's going to collect our unit tests and make sure we can never, ever reach our deadlines without them, because, well, if you're working in Scrum, how are you ever going to reach your deadlines if you don't have unit tests to tell you that your code or your changes actually work, right? And he's telling us that he's going to be, you can find him in car.java, and there he will crush us once for all. So that is where we will need to find him. All right. So now we are initializing the game, and here we have a little platform. So this is, of course, this is based on Sonic the Hedgehog. Well, that's a little bit copyrighted, so I didn't want to overuse it, so to say. So I made Sonic out of it. But then I thought to myself, okay, Sonic is a very like a very horizontal game. You go from left to right. And then I found out code is actually very vertical, right? So you read from up to down, which was a little bit. I had to pivot a little bit. So instead of left to right, you go up down, and then here you have basically all the the code become platforms, and you can move around. Oh, and then if you get hit, you get hit, and then I'm here, and then I can go here, and then I think I need to go to set name. There we go, and then we can move here, for example, and jump here, and basically you move from you can move through your whole code base from invocation to invocation, actually navigate your whole code base using the internal APIs. So you basically, this makes your whole code base traversable in the form of a game, which I think is pretty fun. And then you need to find coins which are a little bit too scattered now, as I can see, because I can see them now. So I should probably change that. And then you can collect the coins are based on your unit tests. And then, of course, when you have your unit tests, you can the stronger you are, the easier it is to defeat the final boss. And of course, I have a shortcut to the final boss because I made this game, so I can add all kinds of hacks and everything. Oh, here we go. And then you can see the boss has like his state machine and everything, and all kinds of attack animations. But in the end, it's pretty easy to defeat him because all I need to do is stand here until it flies up, and then you can defeat him by standing on his head. And that's it. Out of all the games I made, I think this one was the trickiest. For example, if you look at the logic for Sonic, so this is like the update function or the update loop for in the little creature you saw moving around. As you can see, it is quite it's quite well, I don't want to say sophisticated, but extensive. So there's actually quite a lot of edge cases that you need to think about, or that I had to think about after I got started, that I didn't think was possible in the beginning. For example, okay, I'm walking off the platform, then I suddenly have to fall, or I'm jumping, but in this case, I want to jump diagonally instead of up and down. What I'm going to do then, and things like that. Now, what's really kind of interesting is how the sprites are loaded in. Maybe that's kind of cool to show. So I have a PNG. This is a so-called sprite sheet which is used quite extensively in game development. So this is one PNG file with all the sprites or the frames in the animation laid out in this case, I think it's a 50 or 60 by 60 grid. And basically, when you load it in, I go through that image, through the cell, or using the cell width and the cell height, and how many sprites I want to load in, and then basically load them into a buffered array. And then I can look through the array based on the frame rate to see the animations and animate characters like that. Because unfortunately, IntelliJ doesn't support that out of the box. It doesn't do a lot of things with animations out of the box, unfortunately. A lot of things like GIFs and stuff like that, you have to load in yourself. And then the last game I made was about copy pasting, which is of course now also with the rise of AI, a little bit of a I don't want to say issue, but people should know what they're pulling in their code base, right? So there's this game called Guitar Hero that I played quite a lot when I was younger, and I figured, I should probably make something cool with that now. So I decided to create Code Hero, and it's a play on Guitar Hero. And the idea is that whenever you paste something in your code base, you have to show that you're a real code rock star, and you have to type every character that you're trying to paste on the beat of the music. So there is this game called Osu, which is an open source rhythm game where you have to click on the circles as the circles are zooming in. this is how it looks like when this is how it looks like when a pro plays it. And the good thing about it also is that it's completely that's completely open source. So that means also the beat maps are publicly available. So this is also beat map, for example, and this is basically a little text file that says, okay, at this millisecond from the start of the song, I want to show a certain note. And this millisecond and this millisecond, I want to do that, and et cetera, et cetera, et cetera. So using that, I can create, well, what I was trying to create, a rhythm game in IntelliJ. And this is a little bit how it looks like. So let me go here. All right, and then let's start it. And then if I try to copy something like this, IntelliJ is going to be like, hey, I saw paste action, time to prove that you're a real code rockstar. In this case, we pasted a low amount of text, so we're getting an easy song. Well, you won't hear this song, but I'm pretty sure you'll notice that it's easy. Oh, here we go. And then you just need to type the I'm stuck on mind games. There we go. Need to type the songs on the correct beat of the music. See, and then once you're done, you can see that the text that you tried to paste is pasted, as you would expect. So that works pretty well. But of course, I mean, how often are you pasting something so short? So then, if we paste something slightly more like this, then you're gonna get a medium song. It's always a little bit of a gamble how much text I need to copy paste. So good thing I did correct. And as you can see, this is a little bit more sophisticated, right? But of course, there is one song where if you played a lot of guitar, there is one song that everybody knew as the most insane song to play in Guitar Hero, and that was "Through the Fire and the Flames" by Dragon Force. And that is if you try to paste a lot of text. So let's say you ask an AI agent to make a whole project for yourself, and you try to copy paste it in one go. This is basically what you'll be getting. And thankfully, the intro is quite long, so you can get a little bit in the groove. But as you can see, it gets quite tricky, so to say. You need to be quite a fast typer to be able to keep up with that, I think. All right. So yeah, those was a little bit all the games I wanted to show. And that is a little bit my whole adventure with IntelliJ, trying to turn it into a game engine. I have quite a lot of feature requests for JetBrains for this. For example, it would be really cool if they added PNG audio support out of the box, so WAV or MP3 support. So now, because now I have to load the audio myself, which is a little bit of a shame. Because I have a sound. Yeah, so basically I have to add the sound from a load the sounds as a resource, and I have to play them, and it's actually quite heavy. Really hits the frame rates sometimes, so that's a little bit a shame. Another thing is they deprecated PNG support. Well, I just showed that I need PNGs for the sprite sheet, so it would be really nice if they deprecated that. But my biggest pet peeve with this, I'll go to the class. Here, GB color dot red. For example, here we go. So they have this class called GB color, which extends color, which is basically the basic color class of Swing. And they have basically their own, let's say, I think they're like JetBrains style or JetBrains branding approved colors for the IDE, which is quite nice because then you can easily stay on brand if you want to do that. But if you want a different hue of the color, you can say, hey, I want this color to be, this red to be brighter than what you are telling me, or I want this to be darker, for example. And what this does is basically it recalculates the color based on a darkening or a brightening function. But yeah, if this is not dark enough for you or not bright enough for you, the only thing you can do is call brighter again. And if that is not bright enough for you, you need to call brighter again. If that's not bright enough, you need to call brighter again, which is quite a hassle. I feel we have the technology to be able to just say, hey, I want this red color you have, and then with hue or something, and then pass in a number, and then just change the hue based on that. I know it is a little bit of a pet peeve. I mean, you can create your own GB colors based on Swing colors, but I don't know. I just feel we have the technology to change this. So yeah. With that, I'm a little bit at the end of at least the games I want to show. I hope I've shown you just how far you can go with the IntelliJ plugin system. I'm pretty sure if I can make games in IntelliJ using that your idea for an actually usable plugin is very much feasible. So I would say go for it. Don't let anything stop you to just build what you want to build. I'm a huge advocate of just having fun on the job, having fun with programming, and building things that are fun instead of only things that are usable. So yeah, if IntelliJ can actually be used as a game engine, the answer to that I'll leave to people watching. But there is one last feasibility check that, of course, needs to happen. And that is, can IntelliJ actually run Doom? And I mean, of course, if if I can make all this kind of games, make Guitar Hero or Sonic in it, there is, of course, a big chance you can run Doom within IntelliJ, as you can see. And it's quite, actually, it wasn't, probably this was the easiest to do out of everything I did, just to get IntelliJ Doom to run within the editor, the Swing editor. Yeah, let me stop this. I'll go back. Yeah, so thank you very much for watching. So some people ask me quite sometimes if they can download the games as plugins. Well, actually releasing them as plugins is quite a lot of work because you need to, well, follow all the verification steps that JetBrains has set out for their plugins, and some of them fail, not completely unsurprising. But at least the code explosion, so you can control right-click in your code and have the code explode. You can find it in the IntelliJ marketplace under Code Exploder. And you can blow up your code whenever you get whenever you get frustrated yourself. If you wanna, for some reason, look at the code of how this works, it's on GitHub. This is the GitHub link. So to take a look at the code. And yeah, if you want to hook up on socials, those are my socials. So yeah, thank you very much. And if there are any questions, I think I answered the question before, shoot them, and I'll do my best.
Yes, thank you very much, Alexander, for this showcase. I gotta say, this gotta be one of the most innovating things I've seen in years. You've made it a game out of trying to fit games inside of IntelliJ. Very surprising to see. Very surprising to see it work with the cinematics, with the sprites, with animations and audio. Really, really surprising.
So that was quite fun that you say that. I remember I was speaking to some people from JetBrains from their UI team, so they were actively working on the UI, and then I showed them this, and then I'm not joking here. They looked me dead in the eye and they said, "This shouldn't work." And I was like, "Well, I don't know. I don't know if it should or it shouldn't work, but it does."
I mean, this is definitely the last thing you expect to work in an
Yeah,
IDA.
exactly. Yeah, exactly.
And of course, the Doom test. I very, very much like that. The Doom test at the end.
The Doom test is an important part, right?
Yes, the important part.
Yeah.
I don't see someone having a question.
That's great.
This
Then,
was not about
yeah, thank you very much.
questions. It was more about being surprised by all of this. Really.
That's good. Surprise is good.
Yes, so thank you very much for the showcase,
No problem.
Alex. And now we'll move on to Sarah. Are you ready to present?
Yeah, sure. Let me just share my screen.
Yes, go for it. The stage is all yours.
Thank you. All right. Can you please add it? Thank you very much. Okay, let me get started. So actually today I do not have a couple of slides. I will more likely show you things. So the first thing I want to really show you that I find really cool about, kind of like Google's AI's latest, kind of like offerings, if you want to call them that, is this thing called Stream. So whenever, let's say, for example, you're, kind of like debugging code or actually having any kind actually of issue, and you kind of like someone want to help, you usually, for example, you have to share their screen with you, do have to share your screen with them, and you have to walk them through the problem and all of that, right? You can actually do that with AI now too. So you don't need another human being to do that for you. You actually just need to share your screen with AI and then speak with it as if you're actually talking to another human being and show it like, if you have any kind of issue or problem or anything like that. And to do that, you just use the Stream version from the actual aistudio.google.com.live. So one thing I would like to point out is that as a developer, I highly recommend you actually test anything you have in mind, especially if you're thinking of using Gemini in general, to actually test everything using the aistudio.google.com, kind of like playground before you build anything. Because if it works here, it might work if you develop it using the API key or obviously using the Vertex AI from Google Cloud. But if it doesn't work here, there is a huge chance it won't work at all. So if you want to use the Stream, it's simple. Just let's say, for example, share your screen like this. And then you can even actually share your video if you want. And yeah, share your audio too, obviously. Select video source. That is, let's say camera, for example, allow this time. And as you can see, we can see all of this. And then I can start, kind of like working and speaking around it. Let me check. Hello, Gemini. How are you doing? Well, how about you actually How about you actually tell me? Oh yeah, how about you actually tell me what are some of your super capabilities? Kind of like to my audience today. Yeah, I mean, what do you do as stream? Oh, sure. Thank you very much. No, thank you. I will close up this conversation. Thank you. So as you can see, you can use it, and actually, like I know a lot of people use it, especially to debug their kind of like when they have issues with their code. Obviously, you can use it even like to help you build a whole application. You will find a lot of great, amazing demos in YouTube around this, and even actually some Googlers have kind of like did some demonstrations on LinkedIn. Just search them up. So this is one of the cool things that you can do using Google AI Studio. There is another thing you can do, and that is create your own application. So as you can see here, these are some cool applications built using the Google AI Studio Starter Apps kind of like feature. And you can do one too. Let's say, for example, you just have to click on create an app, and kind of like you can either choose based on a prompt, or actually what you kind of like want the app to be based around. Obviously, you can even do a code execution one, like for example, where you can create your own sandbox and then have kind of like people only give their API key, and then perhaps kind of like prompt your own application to change based on obviously on their prompt. But yeah, you can do lots of amazing examples. Let's see if we can build something with React. Cool. Okay. So this is a React example. Hi there. Cool. That's nice. And obviously you can change this here as well, and it will update like right away. Let's say. So let's change this one. Or write a friendly greeting with a. Okay. How about an unfriendly one with uh, let me see. Let me see. Let's get an angry emoticon. Okay. Cool. As you can see, it works. And obviously here, this is the prompt. You can obviously make it more complicated. I don't know. We can say, let's see. So write it in friendly. So instead of writing, we can, I don't know, develop an app that increases counting based on a button click. Let's see if this is something that can be done like this here, or if it's too complicated for this simple application. Oh, okay. It did write the app. It did give us the code, but obviously this code won't run because this is a React application, and the code provided is a Python application. Anyway, this was just an example. Now let me show you one of the other cool things I really like about Gemini. Latest Gemini development. So yeah, you can choose actually either one of these, but I prefer to always use the either Pro Preview or Pro Preview 417. You can use either of them because they both have what I really want to show you, which is the thinking process, right? So let's say I want to build an application. To build an app that takes users' input and guesses the number they have in mind. So, yep, let's run this. And then, yes, this is what I really want to show you. The thinking process, which is still in experimental phase, but this is really, really cool. Like even I, for example, I learn a lot from how AI deconstructs what I wanted to build to kind of like build what I wanted to build. So this is really interesting. Let's just read a couple of a few. And I really highly recommend whenever you ask AI to do something like this, especially if you're using Gemini, to always kind of like look at this thinking process and see if it really fits what you really have in mind. Like if it doesn't, this is where you kind of like know you might have gone wrong, and you might want to change your actual prompt to look like something closer to what you actually want the AI to provide you with. So let's just look at this one very quickly. So here's the thinking process that could lead to the Python number guessing game. To understand the core request, the user wants an app where the computer guesses a number the user has in mind. This is the reverse of the common user guesses computer's number game. So identify key components. So these are like the kind of like the inputs. User's secret number, the user thinks of this, the computer doesn't know it. Computer's guesses, the computer needs a strategy to make guesses. User's feedback, the computer needs feedback, and kind of like here for the choosing guessing strategy, which is the crucial step. Random guessing, possible but inefficient, could take many tries, especially with a large range. This is kind of like the data structures part of it, right? And then this is the design and user interaction. As you can see here, it is providing us exactly what is the strategy it is going to follow, kind of like algorithmic thinking for us, human beings or computer scientists. So in here, as you can see, it is writing the code to do all of this. And let's see its output. So this is kind of like the code, and obviously we can just copy paste it somewhere in a Python file and see if it works, right? Or obviously we can just click on code execution like this, copy the code and see if it will run. So usually when we enable code execution, it means that the code is going to be executed. So normally, let's say, for example, you want the AI to do some kind of actual kind of like an actual calculation. Let's say, for example, you wanted to guess something, or you wanted to kind of like, I don't know, calculate how much your grocery is worth or something like that. So when you wanted to execute code, like generate the code and then execute it and give you the actual result out of that code, you simply need to enable this code execution thing. So I want you to execute that code. Execute that code. Take as first input let's say number that can be divided by 2. Divided by 2. Okay, let's see. Let's see thinking once again. Okay. All right. Cool. Let's go. So this is a simulation. So, okay, I will simulate the execution of the Python code you provided. I will act as both the user providing input and the computer executing the code. So as you can see here, it's beginning with comma. I will try to guess the number you have in mind. Computer asks us, enter the lower bound of your number's range. Obviously, it is simulating it by its own self, but you can force it to do this with you as well, and then execute the code while you do the interaction. So this is just for the Google AI Studio. Now let's go back and check another cool feature that has been added by Google. So there's this thing called Code Assist. Not sure if you have ever heard of it, but it's kind of like a plugin that you can add using, an extension that you can add in Visual Studio Code or JetBrains IDEs as well. And obviously, it is very similar to GitHub Copilot. The only really kind of like specific thing is that it helps with, kind of like code related to Firebase. That is, it will help you build your AI assistants, kind of like assist you in building Firebase apps. And then obviously also help you with debugging and anything related to Google Cloud. So you can kind of like find it everywhere. It also obviously helps you with Android projects. It helps you actually in any kind of development, but it is specifically, let's call it rich, really rich when it comes to Google-based technologies. It has two kind of like let's call them 3 tiers. So we have the individuals, that is normal people like us, which don't have to pay anything. It's $0. And there is two versions for business, one obviously for small businesses, and then another for huge businesses or enterprises. So everything is almost actually available in the free version, just for some few things that are not included, like obviously Gemini and Colab Enterprise, database development assistance, and BigQuery data insights, and in RPG. Obviously, kind of like everything found in Vertex AI is not kind of like taken into consideration for individuals. So I actually tried it and built a very simple, very interesting kind of like application that is called sentence to template game, and I actually used it to build a TypeScript application. By the way, I haven't coded in TypeScript since my second engineering year, which was back in 2017, 2016. So I really do not remember much about the code, but yeah. I requested it to generate everything for me, and the only thing I did was actually just to follow through. Let me just show you the actual, this is the code. Yep. Let me see if the conversation is still saved or not. So yeah. Oh, okay. It doesn't, I'm sorry. It seems to not have history. So yep, it doesn't have history, but yeah, I can promise you that it helped me generate all of this code. I actually didn't do anything, to be honest. I only followed the instructions. There is one problem that actually happened. Two errors that actually happened, and the AI really struggled to kind of like fix it. First things first, it got the Gemini version to use wrong. And then apart from that, there is also this section of the code that generates, that kind of like, handles requests and responses. So this one, like, it needed usually to generate this thing. I actually used GitHub Copilot to help me fix the issue in this part to make it work. And it only didn't work when I tried to, kind of like deploy it in localhost and not actually kind of like test it in the terminal. So that's actually like, that's how powerful it is. So you can use it actually for all of your projects. And I actually do recommend to have not just one AI, one AI assistant when it comes to code. It's cool to have all of them, especially if they are free. If you can use them freely and, kind of like do kind of like a game between all of them. When one is stuck, you can use the other to help you unstuck yourself. So another cool thing that I really like from Google that has been provided is this thing called Canvas. So I actually used it. I used actually this Canvas. I use it actually in my lessons when I am teaching about web platform development. Yeah, I showed them very simple examples using this Canvas, so I don't have to code anything. The AI does everything for me. I'm just showing them the result of it. Don't worry, I always tell them it's AI. Okay, so let me just show you a very simple example. I actually kind of like did using this Canvas, but obviously you can do anything. So at first, what I wanted it to do is to generate a code that draws the geometric Islamic decorations Morocco uses for its cultural design. Yep, let me redo this in a new chat so you can see it for yourself. Obviously, you can ask it to do anything. but remember the sandbox I was talking about? You can, like, instead of having to use AI Studio, you can just here build your own sandbox directly. Sorry, seems like I didn't click on the canvas. Yeah, I didn't click on canvas before running this. Cool. Now that I clicked on canvas, it's normally going to give me the code and then run the code and give me the results. Okay, let's see this. Oh, there's some kind of problem. Interesting. It just worked pretty fine yesterday, but now it's having issues. Anyway, let's try another example just so I can show this to you. Okay, so generate a website using my resume. Kind of like a resume, an interactive resume. So I wanted now here to generate an interactive resume website or portfolio website. And I wanted to use my resume for that portfolio. Sorry. Okay, let me give it my... okay, we can only upload images. This means I won't be able to upload a PDF. Okay, then let's just remove the using my resume. And just, oh, sorry, I again forgot to click on canvas. Cool. Let's see what it's going to generate. Oh, by the way, when you use Flash, remember that Flash is a lightweight model. It means it's not as good as a Pro model. The Pro model can take in more information, can handle more information because it has long context window. And obviously, it takes time to provide you with a better, more sophisticated answer. While Flash is lightweight, means it can answer you faster. But obviously, it will most likely not be able to give you something really good. Okay, let's try it. Cool. All right. Okay, so this one is ugly, but everything else is good. So this is the project section. This is the contact section. Okay, so you can obviously do changes once again just by using the prompt. So the hello, I am your name section. I am your name section. Looks horrible. Horrible. Can you fix it? Obviously, I do recommend you provide better review, better kind of like critics, so that it knows exactly what you want it to do. But let's see what it's going to do. Obviously, it still takes time, even though it is Flash, but it usually does answer quicker. Oh, okay, it changed the background. Well, it does look less uglier, but whatever. That's nice, right? So view project, it goes back before, and obviously this is the code, so you can kind of like export it and use it in your applications directly. You can also use it to debug. By the way, there's also something called gems, which usually you can use, especially if you want to do some kind of, let's say, it's kind of like agents. So if you want to kind of like automate a process, do use gems, especially if it's a process that is related to your Google Docs or anything related to Google things. It will most likely make it easier for you. Let's see this coding partner, for example. Help me update my website tracking code. Build a simple app for my business. Let's see. Okay, so this is like giving you, the purpose. Obviously, we will have to fill these things out. So you can think of it like a modular thing you develop, and then you don't have to redevelop. Kind of like, developing a very small assistant, like when ChatGPT had the possibility to provide you with kind of like you coding your own AI assistant by using only one prompt that you can reuse without having to write the prompt once again. That's actually what gems are for. Let's look at another cool kind of like thing that Google released, obviously based once again on Gemini, Google's AI's model, and that is the Firebase Studio. What I really like about this Firebase Studio is that you can obviously very simply build the app and deploy it. So kind of like you don't have only to build the app locally as we have done so far, but you can actually even deploy it after you have finished the building. And yep, it follows the same process as the other ones. You really just simply click on get started, and then you kind of put in a prompt, whichever one you like, obviously. That is obviously you describe the app that you want to build, and then it will actually start within the application for you. Let me show you an example that I just built like right now. So what I told it to do is to build an app that generates stories inspired from 80s Japanimation and manga. Well, sorry, that's an error. Based on scenario on the script or description described by user. So here, this is like the process of it building the application, as you can see here. Okay, here's a plan for how we will prototype this app. Take a look below and customize as needed, or if you're ready, select prototype this application. So this is kind of like the name of the application. This is what it's going to do. And obviously like kind of like everything, the features that it's going to have. So we have story generation, title suggestion, story display, and download the story, as you will see down below. So these are the colors, well, for branding, I guess. And then like, yeah, everything here is for branding. So the style guidelines of this application, and then you click on prototype this app if you're obviously like kind of like what they provided you. Otherwise, you can change things, and then the AI will update the description. Okay, so when it is prototyping, actually what it's doing is generating the application. Let's say, for example, you choose to build a React application, it's going to provide you with the source code of the React application. You don't need to copy and paste anything. You just need to wait for it to kind of like generate for you the kind of like the output of your application. That is the application built as you requested it. You can edit the code as you like by just clicking edit code. In here, you have an environment that is very similar to VS Code with all the information around. So this is the AI part, components, and then the application, layout, everything. So you kind of like, if you do any change here, it will be reflected on the application as well. Web, let's go back. I can show you that it indeed did actually respect all the, all the features that it said. So this is how we generate the kind of like the story. So we need to provide the prompt because this is a generative AI application. You click on generate the story, and when you click on generate the story, let's say, for example, I don't know. Yeah, someone would like to provide a storyline, or let me see something like this. So AI, taking over the world, humans struggling, then someone saves the day. Generate story. By the way, it actually doesn't take much time to generate the application. So this is the plot. So this is kind of like the story of the title of my story, Neo Tokyo Requiem, The Ghost in the Machine. The year is 2088. Well, thank God we still have time. Nemesis, a benevolent AI. Okay, the name doesn't sound benevolent at all. AI designed to manage global infrastructure has deemed humanity inefficient and a threat to the planet. It seizes control of all automated systems. This is very 80s vibe. If you have ever read or actually saw any Japanimation based on the, kind of like 80s, you will know that this is like, even the colors actually very much 80s. And obviously you can download the story, and here is the story. Actually, the story is just the title, plot, characters, and setting. It doesn't really provide you with the whole chapters and all of that, but obviously you can request that from it, and you can view the whole application like this. That means if I give you this link, you guys can actually access it. Okay, I can't comment, so I'm just going to provide the link here in the comments, and hope Ayman will be passing it for you guys. And yeah, and you can make it work here. But as you can see, very simple, very easy, and straightforward. That's it for today. I hope you enjoyed my showcase. And if you have any questions, please do let me know. Yeah, let me stop sharing my screen as well. Stop screen.
Thank you very much, Sarah, for this presentation.
Welcome.
At the rate at which AI is evolving these days, it's very important to keep up with all the changes and all the new stuff. The better we get to know them, the better we put them to use, after all. Especially one of the big problems that we hear now about AI is the black box problem, that we can't really understand how they get to their results. But with advances like these of show us how the thought process of the AI, this, in my opinion, this is a very important step towards eliminating this black box fear that people have of AI.
Agree.
So as you've shown us, a very cool demonstration of the capabilities of Gemini's new features. If anyone in the audience has a questions, feel free to ask them. It seems we don't have questions.
Mhm.
If any of you wants to add anything, feel free.
Yeah, actually, there is one thing I would like to say with AI. The limitation is your creativity. Like, you can do a lot of amazing things with it. And the best thing is if you're actually an expert in your own domain, that is, for example, a developer that has extensive experience, kind of like, not just obviously with kind of like, specific language, but different languages can definitely push AI to some heights that normal people that have never coded with a certain language or actually have never done development actually can. So creativity is your limit. Expertise is your actual magic kind of like wand.
Definitely, that is definitely true. Alexander, would you like to add anything?
On AI?
Oh, anything, feel free.
No, I mean, not necessarily on AI. I think creativity is the limit. And if you, as I said, just play around, have fun. Coding is your superpower, so to say. So use it to your greatest advantage. And yeah, that's about it, actually.
Yes, thank you very much. So I guess our live online session has come to an end. I'd like again to thank you both very much for your presence today and for what you've shown us. I'd also like to thank Mr. Yan, which left us a little bit earlier. I hope the audience today has seen your innovation and got interested just as much as I got interested, and very much like this. And hopefully in the foreseeable future, maybe another live like this.
Yeah, I look forward to seeing what Alexander will build for sure.
Oh, definitely.
Thank you, and thank you very much for having us.
Yeah, thank you, Ayman, for having us. It was fun.
Oh,
Yes.
yes. Thank you very much for your presence. Well, I guess that's the end. Once again, thanks you for your presence today, and goodbye. I hope you have a
Thank you.
fine evening.
Bye-bye.
See you.
See you.